July 1st, 2025, astronomers discovered an object arriving from beyond our solar system, the third interstellar visitor ever detected. They named it 3I/Atlas. Within weeks, scientists noticed something wrong. The chemistry didn't match any comet they'd ever studied. The trajectory defied statistical probability. The behavior broke rules we thought were universal. By October, 7 spacecraft positioned at Mars to capture the closest view ever of an interstellar object. Cameras powerful enough to photograph features smaller than a kitchen table. Then NASA went silent. 15,000 employees were sent home. Government shutdown on the exact day of closest approach. And when images finally emerged, they showed nothing but a fuzzy white dot. 4 months later, we still don't have answers. But we have something more unsettling, a pattern of anomalies that keeps growing. Each one explainable on its own, all of them together nearly impossible to dismiss. July 1st, 2025. The Atlas Survey Telescope Asteroid Terrestrial Impact Last Alert System detected a faint moving object in the night sky. Initial calculations showed it was traveling fast, very fast, too fast to be bound to our sun's gravity. This was the signature of an interstellar object, something that formed around another star, got ejected somehow, and spent millions or billions of years drifting through the void between stars. Until it happened to pass through our neighborhood. The discovery itself wasn't shocking. We knew interstellar objects existed. We'd seen 2 before. Oumuamua in 2017, 2I Borisov in 2019. But as observations accumulated over the following weeks, something became clear. 3I Atlas wasn't behaving like its predecessors. First anomaly anyone noticed was the orbit. Every object in space follows an ellipse or hyperbola determined by gravity and velocity. The math is precise. Newton figured it out 300 years ago. 3I Atlas follows a hyperbolic trajectory, as expected for interstellar visitor. But the angle of that trajectory, the inclination relative to Earth's orbital plane, sat at just 4.89 degrees. Think about what that means. Objects from interstellar space can arrive from literally any direction. Up, down, sideways. The celestial sphere offers infinite approach angles. Less than 5 degrees from our orbital plane puts 3I Atlas in the flattest 1% of possible trajectories. Harvard physicist Avi Loeb ran the numbers. He calculated that for random interstellar object, probability of arriving at this shallow angle is roughly 0.2%, 1 in 500. His colleague pushed back. Maybe the calculation was too conservative. Maybe true probability closer to 5 or 10% when accounting for observational biases. Fine, even at 10%, you're looking at something that should only happen once in every 10 interstellar objects we detect. We've detected 3 total, and the third one is the statistical outlier. Loeb published his analysis in July. Most astronomers shrugged. Low probability doesn't mean impossible. Unlikely things happen, that's how probability works. But then the chemistry results started coming in. Late August 2025, the Very Large Telescope in Chile pointed its UVES spectrograph UVES at 3I Atlas. Spectrographs split light into component wavelengths. Each chemical element absorbs and emits light at specific frequencies. By analyzing the spectrum, you can determine what something is made of, even from millions of kilometers away. The VLT data showed nickel, lots of nickel, roughly 100 kilograms per second being released as gas from the comet's surface. That's not unusual by itself. Comets contain trace metals. When solar radiation heats the surface, these metals vaporize and show up in the spectrum. But here's what stopped scientists cold. The data showed almost no iron. In the universe, nickel and iron are twins, born together in the same stellar furnaces. When massive stars explode as supernovas, they forge heavy elements through nuclear fusion. Nickel and iron form in the same processes in roughly fixed ratios. You find them together everywhere, in meteorites, in asteroids, in every comet ever analyzed. 2I Borisov, the previous interstellar comet, showed normal nickel to iron ratios. Every comet in our solar system shows normal ratios. 3I Atlas is producing abundant nickel with virtually no iron. The scientists who published this finding were careful in their language. They called it extremely puzzling. They noted the temperature at the comet's distance from the sun was far too low to vaporize the refractory minerals containing these metals under normal conditions. They proposed some chemical pathways that might, possibly, under very specific circumstances, explain it. But you could feel the uncertainty in their prose. On Earth, there's one place we commonly see nickel without iron: industrial refinement. When we manufacture nickel alloys for electronics or specialized materials, we deliberately remove iron contaminants. The process leaves a signature, pure nickel. Nobody was saying 3I Atlas was manufactured, but the chemistry looked wrong for a natural object, and it wasn't static. As the comet got closer to the sun, nickel production increased exponentially, following a power law of roughly 9. That means for every 10% decrease in distance, nickel output increased by a factor that climbs steeply. This isn't random outgassing. This is a process that ramps up systematically as solar energy increases, almost like something activating. September 2025, Hubble Space Telescope captured high-resolution images of 3I Atlas. Comets are easy to recognize. They have a fuzzy coma, temporary atmosphere of gas and dust, and a tail that always points away from the sun. The tail forms because solar radiation pressure pushes dust particles outward. It's consistent, reliable. Every comet ever photographed shows this. 3I Atlas showed something different. The scattered light around the object extended roughly twice as far toward the sun as it did perpendicular or opposite to the sun. Read that again. More material sunward than anti-sunward. This violates basic physics. Solar radiation should push particles away, not pull them closer. Avi Loeb and his colleague Eric Quito published a paper offering an explanation. Maybe the comet was shedding large ice fragments from its sun-facing side. These fragments, being bigger, would resist radiation pressure better than small dust particles. As they slowly drifted outward, they'd sublimate, creating an extended region of gas and dust in the solar direction. The physics worked on paper. Ice fragments of specific sizes, ejected at specific velocities, under specific heating conditions, could create the observed distribution. But those conditions were incredibly narrow. You needed preferential ejection from the day side. You needed fragments large enough to resist radiation, but small enough to scatter visible light efficiently. You needed the evaporation rate perfectly balanced. It's possible. Same way it's possible to flip a coin 50 times and get heads every time. The laws of physics don't forbid it, but the improbability makes you wonder. Other astronomers suggested alternative explanations, maybe unusual dust grain properties. Maybe viewing geometry created optical illusion. Each explanation required its own set of special circumstances. And this became the pattern. Every anomaly had a natural explanation that worked. If you were willing to accept that 3I Atlas was uniquely configured in ways no other comet had ever been. Early September. Scientists analyzing astrometric data, precise measurements of the comet's position over time, noticed something else unusual. When comets approach the sun, outgassing creates jets of material shooting off the surface. These jets act like tiny rocket engines, pushing the comet slightly off its gravitational trajectory. The effect is called non-gravitational acceleration. We see it in every active comet. 3I Atlas showed almost no deviation from pure gravitational motion. At first, scientists thought maybe the outgassing was symmetric, jets pointing in all directions, canceling each other out. But the comet was clearly active, releasing 100 kilograms of material per second, creating a visible coma. That much activity should produce measurable thrust, unless the object was incredibly massive, so heavy that even continuous jetting barely budged it. The calculations suggested a nucleus diameter larger than 5 kilometers, mass exceeding 33 billion tons. For comparison, Oumuamua was roughly 100 meters across, 2 I Borisov less than 1 kilometer. 3 I Atlas appeared to be roughly 1 million times more massive than Oumuamua. 1 million times. That's not a small difference. That's the difference between a grain of sand and a boulder. But here's the problem. Objects that large should be incredibly rare. The statistical models predicting how many interstellar visitors we should detect are very clear. Small objects are common. Large objects are exceedingly rare. We should have found hundreds, maybe thousands of Oumuamua-sized visitors before stumbling across something the size of 3 I Atlas. The probability of detecting such a massive object as only our third interstellar discovery? Roughly 0.01%, 1 in 10,000. Add that to the trajectory anomaly and the chemical impossibility. 3 low-probability events stacking up in the same object. August 15, 1977, the Big Ear radio telescope at Ohio State University was conducting a routine SETI survey, Search for Extraterrestrial Intelligence. At 11:16 p.m. Eastern Time, the telescope detected a narrowband radio signal at 1420 by 4556 MHz. This is the natural emission frequency of hydrogen, the most abundant element in the universe. Any technological civilization trying to send a detectable signal would logically broadcast at this frequency, because every other civilization would be listening there. It's the cosmic equivalent of choosing the most obvious meeting place. The signal lasted exactly 72 seconds, the duration it takes Earth's rotation to sweep the telescope's beam across any fixed point in the sky. The intensity climbed steadily, peaked, then declined symmetrically. Perfect signature of a stationary source being scanned by a moving detector. Astronomer Jerry Amon was reviewing the printout the next morning. He saw the intensity values climbing 1, 2, 3, 5, 6. Then the letter U, the highest value the system could print. He grabbed a pen and wrote one word in the margin. Wow. They searched for it again, for years, decades. The Big Ear telescope pointed at that same patch of sky hundreds of times. Other observatories joined the search. Nothing. The signal never repeated. For 48 years, the WOW signal remained unexplained. Evidence of nothing, proof of nothing. But impossible to forget. Then, Avi Loeb calculated where 3 I Atlas was in August 1977. The answer, approximately 600 astronomical units from Earth. 1 astronomical unit is the distance from Earth to Sun. 600 AU is roughly 90 billion kilometers. More importantly, he calculated what direction the object was coming from at that time. Right ascension, 19 hours, 40 minutes. Declination, 19 degrees. The WOW signal originated from right ascension, 19 hours, 25 minutes. Declination, negative 27 degrees. The two positions separated by approximately 9 degrees. In the vastness of space, with random objects arriving from literally any direction, the probability of this alignment is roughly 0.6%. Loeb didn't stop there. He asked the next logical question. If 3 I Atlas transmitted the WOW signal from 600 AU away, how powerful would the transmitter need to be? The detected signal strength was between 54 and 212 Janskis across a 10 kHz bandwidth. At that distance, producing that intensity requires a transmitter outputting between half a gigawatt and 2 gigawatts. For reference, a typical nuclear power plant on Earth produces about 1 gigawatt. So we're talking about nuclear reactor levels of energy, focused into a narrow radio beam, transmitted across 90 billion kilometers. Not impossible for an advanced civilization. Actually quite reasonable if you're trying to send a detectable signal across interstellar distances without wasting energy, broadcasting in all directions. One more detail. The WOW signal was blue shifted by approximately 10 kilometers per second toward Earth, relative to the hydrogen line. Blue shift indicates the source was moving toward us. 3 I Atlas is currently approaching the Sun at roughly 60 kilometers per second. Loeb suggested that if the object has maneuvering capability, it could have been traveling slower in 1977. then accelerated after detecting habitable zone planets in our solar system. A reconnaissance pulse, checking for signs of technological civilization before committing to closer approach. Now here's what makes this entire connection so frustrating. It would be trivially easy to test. Point a radio telescope at 3I Atlas. Listen at the hydrogen line frequency. If it's transmitting, we'll detect it within hours. Simple test, definitive answer. As of October 2025, not a single radio telescope has published observations of 3I Atlas. The Very Large Array hasn't looked. The Arecibo telescope in Puerto Rico collapsed in late 2020. Greenbank Telescope in West Virginia hasn't released data. Even SETI, the organization literally dedicated to finding extraterrestrial signals, hasn't publicly announced monitoring efforts. The silence from the radio astronomy community is notable. October 3, 2025, 3I Atlas made its closest approach to Mars. Distance, approximately 29 million kilometers. 7 spacecraft were positioned to observe. NASA's Mars Reconnaissance Orbiter with its HiRISE camera, high-resolution imaging science experiment, the most powerful camera ever sent to another planet. From Mars orbit, HiRISE can photograph features the size of a kitchen table on the Martian surface. Pointed at 3I Atlas, it had resolution of approximately 30 kilometers per pixel. For comparison, the estimated nucleus diameter is between 5 and 46 kilometers. If there's structure, if there's anything unusual, anything that doesn't fit the natural comet narrative, HiRISE would see it. The European Space Agency had 3 spacecraft watching: ExoMars Trace Gas Orbiter with its CASIS camera, Mars Express, and another orbiter. China's Tianwen-1 was in position. The UAE's Hope probe had a clear shot. This was the observation opportunity of a lifetime. Multiple spacecraft, multiple angles, unprecedented resolution of an interstellar visitor. Scientists had been building toward this for months, calculating optimal observation windows, planning instrument sequences, preparing for data that could definitively characterize this object. Then, at midnight on October 1st, the United States federal government shut down. By morning, 15,000 NASA employees had received furlough notices. Over 80% of the agency's workforce sent home. Labs went quiet, offices closed, the NASA website stopped updating, public communications ceased, only essential personnel remained, mission control for the International Space Station, ground support for active spacecraft. About 3,000 people required to work without immediate pay. The Mars Reconnaissance Orbiter kept operating. Its cameras still functioned. Data still flowed back to Earth. But there was nobody to process it, nobody to release it to the public, nobody available to answer questions about what had been observed. The official explanation was straightforward. Budget impasse in Congress, nothing to do with 3I Atlas, just unfortunate timing. Unfortunate timing. Those 2 words doing a lot of work to explain why the world's premier space agency went dark, precisely when an object exhibiting multiple statistical impossibilities passed within photographing distance of our Mars spacecraft. Think about the odds. 3I Atlas was discovered in July. The Mars flyby date was known months in advance. Scientists had been planning observations since summer, and in the final week before closest approach, the government shut down. But wait, NASA is American, the European Space Agency is not. China's space program answers to Beijing. The UAE's Hope mission is run from Abu Dhabi. 4 separate space agencies, 4 sovereign governments, completely independent bureaucracies and funding structures. NASA's shutdown should have no effect on ESA, China, or the UAE. And yet, as October progressed, all of them remained silent. October 7th, 2025. 4 days after the flyby, the European Space Agency finally released images from their ExoMars orbiter. Months of hype, promises of unprecedented views, the closest observation ever of an interstellar visitor. The images showed a fuzzy white dot, moving slowly across a star field. No detail, no structure, nothing that would help determine what we were looking at. The backlash was immediate. An account called Astronomy Vibes posted a side-by-side comparison on Twitter. On the left, a crisp, detailed image of Comet Lemon captured by an amateur astrophotographer using a simple mirrorless camera from his backyard. On the right, ESA's image of 3I Atlas taken by spacecraft costing billions from just 30 million kilometers away. The caption read, "If a simple camera can catch Comet Lemon, why can't NASA capture 3I Atlas passing close to Mars?" The post went viral, 40,000 reposts within 24 hours. To understand the anger, you need to understand the technical specifications. The Cassis camera aboard ExoMars has angular resolution of 11.36 microradians per pixel. At 30 million kilometers, that translates to 340 kilometers per pixel. The estimated nucleus of 3I Atlas is between 5 and 46 kilometers across. That means the entire solid core occupies, at best, a fraction of a single pixel. But ESA knew this going in. Nick Thomas, the principal investigator for Cassis, admitted as much in the official statement. This was a very challenging observation. The comet is around 10,000 to 100,000 times fainter than our usual target, Mars. So why release images you know are inadequate? Why build expectations for months, only to deliver something that provides zero new information? The timing felt deliberate. Give people something to look at while the real data stays locked away, because there are better images, much better images. NASA's HiRISE captured them. Resolution more than 10 times better than ESA achieved. If anything unusual exists on or around this object, HiRISE saw it. Avi Loeb wrote in his blog on October 7th, "We are all hoping the HiRISE team will release their images as soon as possible." That was October 7th. As of late October, still nothing. Government shutdown excuse applied. No staff to process release requests. Nobody available to provide even basic metadata about exposure times or image parameters. But China and the UAE weren't shut down. Their spacecraft had clear shots. Their imaging teams were fully staffed. Also silent. 4 space agencies, 4 governments. All simultaneously unable or unwilling to release their best data on the most scientifically significant interstellar object in years. The pattern is hard to ignore. October 3rd, same day as the Mars flyby. A Portuguese amateur astronomer using the name Dobsonian Power uploaded an image to social media. He'd used a solar telescope from his backyard. Wrong equipment entirely for deep space objects. Solar telescopes use specialized filters designed for the sun's extreme brightness, not faint comets millions of kilometers away. But with aggressive digital enhancement, he captured something. The image showed angular structures within 3I Atlas. Dark geometric shapes, protrusions that didn't match the typical diffuse glow of a comet's coma. His caption was simple but loaded. What on earth is it? Within 6 hours, the image was everywhere. Astronomy forums, Reddit, Twitter, Facebook. Reactions split immediately. One group saw evidence of artificial structures, proof that 3I Atlas wasn't what mainstream science claimed. The other group dismissed it as pareidolia, the human tendency to see patterns where none exist, processing artifacts from inappropriate equipment. The debunkers had solid technical arguments. Solar telescopes simply aren't built for this kind of observation. Add aggressive digital enhancement to compensate for inadequate equipment, and you're asking an algorithm to invent details that aren't really there. Fair point. But here's what complicated things. Dobsonian Power isn't some conspiracy theorist with a cheap telescope. He's been sharing legitimate astrophotography work for over a decade. His YouTube channel features careful documentation, equipment specifications, processing workflows, educational content about how to capture and enhance astronomical images properly. When pressed about the anomalous structures in his 3I Atlas image, he didn't double down with wild claims. He acknowledged uncertainty, promised to try again in November when the object becomes visible from Earth again. Measured, scientific, appropriately cautious, which makes the response to his image more telling. Within 24 hours, multiple websites published articles specifically debunking his capture. Amateur telescope captures strange image. Here's why it's not what it seems. The timing felt coordinated. The tone felt defensive, as if someone needed to establish the narrative quickly before the image gained too much traction. Then the enhancement wars began. Users across Reddit and Twitter started downloading the official ESA images and running them through their own processing algorithms. Some used standard astronomical image stacking techniques. Others employed AI upscaling tools designed for enhancing low-resolution photos. A few went completely experimental with machine learning models trained to reconstruct fine details from limited data. Results varied wildly. Some showed slightly sharper versions of the same fuzzy dot. Others revealed what appeared to be geometric patterns, edges, structures too regular to be natural. But once you start aggressively processing an image, especially with AI tools, you're no longer looking at what's actually there. You're looking at what an algorithm thinks should be there based on its training data. If you train AI on thousands of spacecraft images, then ask it to enhance a blurry dot, it might very well invent spacecraft-like details. That's what it learned to recognize. Scientific dead end wrapped in illusion of clarity. The proliferation of enhanced images had an unintended effect. It muddied the water so thoroughly that distinguishing legitimate observations from outright fabrications became impossible. Within 48 hours, dozens of supposedly enhanced versions circulated online. Some showed metallic surfaces, others depicted what looked like solar panels or antenna arrays. A few even included running lights and visible thrusters. Most were obviously fake. Digital art by people with too much Photoshop skill and too much time. But mixed in with the noise were a handful that felt different, more subtle, less sensational, showing just enough unusual regularity to make you wonder. October 4th, 2025, an anonymous user on 4chan's paranormal board posted what they claimed was insider information. The post was titled simply, ESA Data Leak. It began, I am a doctoral researcher working with the European Space Agency with continuous access to the combined observational data of 3I Atlas. Internet leaks are common. Most are creative fiction or trolling. But this one felt different. The level of technical detail was unsettling. The poster didn't make wild claims about alien invasions or secret military operations. Instead, they laid out specific observational anomalies that, if true, would fundamentally challenge our understanding of what 3I Atlas is. First claim, chemical impossibility. According to the post, spectroscopic analysis shows the object releasing approximately 100 kilograms of nickel gas per second, but with almost no iron emission. We already knew this from published VLT data. But the poster added details not in the public papers. Second claim, thermal contradiction. The object releases massive amounts of gas and dust, signature of an active comet being heated by the sun. But infrared observations show it remains cold, far colder than it should be, given its outgassing rate and proximity to solar radiation. The poster compared it to watching someone sweat profusely in a freezer. The physics don't match. Third claim, trajectory precision. The post referenced Avi Loeb's public calculations about the shallow orbital inclination, but added something Loeb hadn't emphasized. The trajectory isn't just unusual, it's a perfect straight shot from the direction of the galactic core. No wobble, no deviation, no signs of gravitational perturbation from nearby stars during millions or billions of years traveling through interstellar space, as if it was aimed. Then came the part that elevated this from interesting speculation to something darker. The poster claimed the object fits the profile of what they called a post-biological entity. Not a natural comet, not a conventional spacecraft. Something in between. They described it as having a 3-phase particle engine with estimated power output of 75 megawatts, continuously transmitting an active signal, probing our solar system. The post concluded with theoretical framework. The poster suggested 3I Atlas might be a macroscopic quantum object, specifically a cue ball. This is an exotic theoretical construct from particle physics. a type of non-topological soliton, soliton, that could theoretically exist at scales far larger than subatomic particles. If stable, a cue ball could have properties that seem impossible under normal physics. It could be incredibly dense while appearing diffuse. It could absorb and redistribute energy instantaneously across its entire structure. It could even explain the nickel without iron problem if the cue ball's internal quantum state preferentially produces certain isotopes. Within 18 hours, the post had been screenshot and shared everywhere. A Reddit thread discussing it accumulated over 2,000 comments before moderators locked it for violating rules against unverified claims. Locking the thread didn't stop the conversation, it just fragmented into dozens of parallel discussions, each pulling the original post in different directions. Some focused on the chemical anomalies, others zeroed in on the cue ball hypothesis. A few started connecting it to earlier speculation about 3I Atlas potentially being the source of the 1977 WOW signal. The post couldn't be verified. The poster remained anonymous. No credentials could be checked, no institutional affiliation confirmed. It could be entirely fabricated. Creative fiction by someone with enough technical knowledge to sound credible. Or it could be exactly what it claimed to be. A researcher with access to unpublished data, troubled by what they're seeing, choosing to leak information anonymously because official channels remain closed. We have no way to know which. October 4th, 2025. NASA's Perseverance rover sitting in Jezero crater on Mars captured something in the night sky. The right navigation camera showed an elongated streak of light, roughly 4 times longer than it was wide. At first glance, typical long exposure of a moving object. Comets and asteroids often appear smeared when the camera tracks stars instead of the object itself. Standard stuff, except people started calculating, using Perseverance's known camera specifications and the distance to 3I Atlas at the time of observation. They arrived at a disturbing number, 50,000 kilometers long. That's not a comet nucleus. That's not even a comet with a tail. That's something else entirely. For comparison, Earth's diameter is less than 13,000 kilometers. If this streak represented actual physical size, we were looking at an object nearly 4 times wider than our entire planet. Social media exploded with speculation. Was 3I Atlas actually a massive cylindrical craft? Had it been hiding its true size behind a diffuse cloud of gas and dust? The timing felt significant. This image emerged one day after the Mars flyby, right when all professional space agencies went quiet. Some saw it as confirmation that something deeply anomalous had been photographed, something that couldn't be easily explained away. The speculation reached high enough that Representative Anna Paulina Luna, a member of Congress known for her interest in unexplained aerial phenomena, reached out directly to Avi Loeb for analysis. Think about that. A sitting member of the United States House of Representatives felt compelled to contact a Harvard physicist about a photograph from Mars. That's not normal protocol. Loeb's response was thorough and, on the surface, reassuring. He calculated that Perseverance's navigation camera has angular resolution of 0.33 milliradians per pixel. At the distance of 3I Atlas when the image was taken, approximately 38 million kilometers, that translates to about 12,500 kilometers per pixel. The streak spans roughly 4 pixels. That gives you the 50,000 kilometer length. But Loeb argued this was an artifact of composite imaging. The streak wasn't showing the object's actual size. It was showing the path the object traced across the Martian sky during a long integration time, likely around 10 minutes of stacked exposures. His reasoning was solid. Mars orbits the Sun at 24 kilometers per second. 3I Atlas was traveling at 67 kilometers per second relative to the Sun in the opposite direction. That gives a relative velocity of over 90 kilometers per second compared to Mars. Over 10 minutes, that's exactly 54,000 kilometers of travel, perfectly matching the observed streak length. The shape wasn't the object, it was the object's motion, smeared across time. Case closed. Cylinder theory debunked by basic physics and careful math. except Loeb included one sentence that conspiracy theorists latched onto. He wrote, "If the navigation camera images represent single snapshots with exposure time below 3.28 seconds, then the brightness and angular length of the observed source imply it is not 3I Atlas. In that case, the source might be much closer to the camera. Wait, if these are single-frame captures, then what Perseverance photographed wasn't 3I Atlas at all. It was something else, something closer to Mars." That qualifier opened a door that no amount of subsequent clarification could fully close. NASA hasn't confirmed whether the image is a composite or a single frame. They haven't released the metadata, they haven't provided exposure time or the number of stacked images. Government shutdown excuse applies here too. No staff to process requests, no one available to confirm basic technical details. Something strange started happening around October 5th, 2025. Users across multiple platforms began reporting that their posts about 3I Atlas were disappearing. Not being flagged as misinformation, actually vanishing. A Reddit user documented the pattern. They posted a detailed thread analyzing the chemical anomalies from the alleged ESA leak. The thread gained traction, hundreds of upvotes, dozens of comments within 2 hours. Then it was gone. Not removed with a moderator explanation, deleted from existence. When the user tried reposting, the submission wouldn't go through. Shadow banned without notification or explanation. On Twitter, now called X, several accounts noticed similar patterns. Astronomy Vibes, the account that went viral criticizing the ESA photos, reported significant engagement drops after October 7th. Posts that normally reach tens of thousands of people were suddenly plateauing at a few hundred views. No official restrictions, no warning messages, just algorithmic suppression. Quiet enough to be deniable, aggressive enough to be effective. Other creators in the space and astronomy community noticed the same thing. Videos about 3I Atlas that would typically perform well were getting a fraction of their usual reach. YouTube presented a different problem. Content creators who posted analysis videos speculating about 3I Atlas began receiving demonetization notices. The stated reasons varied. Some were flagged for discussing sensitive topics without proper context. Others were categorized as potentially misleading content about scientific matters. A few got hit with a vague but ominous label. Content may not be suitable for all advertisers. The pattern was clear. Make a video saying 3I Atlas is definitely just a comet. Mainstream science has it figured out. That was fine. Monetized, promoted, suggest there might be anomalies worth investigating. Suddenly your video becomes advertiser unfriendly. Facebook's approach was the most overt. The platform's fact-checking system, operated by third-party verification organizations, started aggressively labeling 3I Atlas content. Posts sharing the 4chan leak got slapped with missing context warnings. Claims about the trajectory anomalies were flagged as partly false, even when the posts were just quoting Avi Loeb's published calculations verbatim. The fact-check articles offered reassurance. Space agencies confirmed no threat from interstellar comet. Experts say unusual features likely natural processes. The subtext was clear. Don't worry, don't speculate. Trust the authorities, move along. The timing felt coordinated. All of this ramped up within 48 hours of the ESA photo release, right when public frustration was peaking over the lack of quality images. Now, social media platforms suppress content all the time. Algorithms change, engagement fluctuates, fact-checkers flag misinformation. These are normal platform operations, unless there's a pattern. Unless it's happening all at once, targeting one specific topic, right at the moment when public interest is highest and official answers are most absent. Some creators started using coded language to avoid suppression. Instead of 3I Atlas, they'd say the visitor or the object. Instead of alien or extraterrestrial, they'd use non-terrestrial or anomalous. It was like watching people develop new vocabulary to discuss something the platforms didn't want discussed openly. The Streisand effect in real time. The more content got suppressed, the more people assumed there was something worth hiding. The more aggressively fact-checkers pushed back, the less people trusted the official narrative. Every attempt to manage the conversation amplified the suspicion that the conversation needed managing. October 1st, 2025. While everyone watched 3I Atlas, something else passed between Earth and our satellites. Asteroid 2025 TF, roughly the size of a giraffe. It came closer to our planet than the International Space Station orbits. We had no idea it was coming. By the time astronomers spotted it, the asteroid was already gone, slipped back into the darkness like a shadow that forgot to announce itself. Think about that for a moment. We can photograph distant galaxies forming billions of years ago. Yet a rock close enough to practically scratch our atmosphere went completely unnoticed until it was already in our rearview mirror. The asteroid measured somewhere between 1 and 3 meters wide, small enough that had it entered our atmosphere, it would have burned up as a brilliant fireball. Nothing that would threaten cities or civilizations. But here's what keeps astronomers awake at night. If we cannot reliably detect something this close, traveling at speeds that would cross the United States in less than a minute, what else might we be missing? ESA and NASA track thousands of near-Earth objects, carefully cataloging which pose greatest collision risk. To be classified as potentially hazardous, asteroid must measure at least 140 meters diameter. Follow orbit, bringing it within 7.5 million kilometers of Earth. Roughly 20 times distance to Moon. 2025 TF falls far short of size threshold. Partly explains why it evaded detection. Our telescopes prioritize finding big ones, civilization enders, objects that could create extinction event. But this tiny visitor reminds us space is not empty, it churns with debris, ancient fragments from solar system formation, pieces of shattered worlds that never quite became planets. Most stays far away, locked in stable orbits in asteroid belt between Mars and Jupiter, or drifting in distant Kuiper belt beyond Neptune. But gravitational interactions, subtle tugs of Jupiter's immense mass, or nudge from passing comet can shift orbits, sending rocks on new trajectories that sometimes intersect with ours. What makes 2025 TF particularly interesting, not just that it came close, but that it came close during month when sky seemed unusually busy with visitors. While one traveler slipped past unannounced, another was making much more theatrical entrance. While asteroid surprised us, another visitor was lighting up October skies. Comet C2025A6, better known as Lemon after observatory that discovered it. Brightening, approaching Earth, astrophotographers around world capturing increasingly dazzling images as this ball of ancient ice and dust makes its way toward close approach. Unlike stealth asteroid, Lemon tracked carefully since discovery, right now sits at edge of naked eye visibility. Over next weeks, if conditions right and skies dark enough, you might step outside and see it yourself. Faint smudge of light with ghostly tail stretching away from sun. Comets fundamentally different from asteroids. Asteroids are rocky or metallic, solid chunks formed in warmer inner solar system. Comets are icy bodies from cold outer reaches, sometimes called dirty snowballs, though that sells them short. Comet nucleus contains frozen water, carbon dioxide, methane, ammonia mixed with dust and organic compounds. Chemical building blocks of life. As comet approaches sun, solar radiation warms surface. Ice sublimates, turns directly from solid to gas without becoming liquid. This creates coma, temporary atmosphere of gas and dust stretching for hundreds of thousands of kilometers. Solar wind and radiation pressure push material away from nucleus, forming characteristic tail that always points away from sun, regardless which direction comet travels. Lemon not only comet gracing our skies this month, another visitor, C2025R2, known as Swan, slides past Earth later in October at distance of 0.26 astronomical units. Close enough to put on show for those with binoculars or small telescopes. Both comets currently shine around magnitude 6, right at threshold of human vision under perfect conditions. But comets notoriously unpredictable, can suddenly brighten if rotation exposes fresh ice to sunlight, or if outburst sends plume of material into space, can also fragment, breaking apart under stress of solar heating or tidal forces, creating multiple nuclei that each develop own coma and tail. What draws people to watch comets beyond beauty is connection to deep time. Ice in these objects formed billions of years ago in outer solar system, preserved in cosmic freezer far from sun's warmth. When we see comet, we're seeing material that existed before Earth had oceans, before Moon was fully formed, before life emerged in whatever warm tidal pool or deep sea vent first gave rise to self-replicating chemistry. Some scientists believe comets delivered significant amounts of water to early Earth, raining down in bombardment that helped fill our oceans. Others suggest organic molecules found in comets, including amino acids, building blocks of proteins, may have seeded our planet with raw materials needed for life to begin. This connection between ancient comets and origin of life brings us back to 3I Atlas. Because if comets can carry building blocks of life, if they can deliver water and organics to young planets, what else might they carry? Late August, early September 2025, Very Large Telescope in Chile trained its UVES spectrograph on 3I Atlas. What they detected stopped scientists cold. Nickel atoms in gas plume, lots of nickel, rising exponentially as object approached sun, increasing by power law of roughly 9. But here's the problem. They detected almost no iron. In nature, nickel and iron are born together in supernova explosions. They occur in roughly fixed ratios. Every natural comet ever observed shows nickel and iron in similar abundances. 2. E. Borisov, previous interstellar comet, had normal nickel to iron ratios. Every solar system comet has normal ratios. 3. I Atlas, producing nickel without iron. The only place we see that signature is in industrial production. Nickel alloys, materials deliberately refined and separated. Scientists who published this data were careful in wording, called it extremely puzzling. Noted temperature at objects' distance from sun far too low to vaporize refractory minerals containing these metals under normal conditions. They proposed some chemical pathways that might explain it, but you could feel uncertainty in prose. And it's not static. Nickel production increases with decreasing distance from sun, exponentially, by power law of roughly 9. That means every time object gets 10% closer, nickel output increases by factor that climbs steeply. This is not random outgassing, this is process ramping up as solar energy increases, almost like something powering on. Now add the thermal contradiction from the 4chan leak. Object releasing massive amounts of gas and dust, signature of active comet being heated, but infrared observations show it remains cold, far colder than it should be given outgassing rate and proximity to solar radiation. The physics don't match observation. It's like watching someone sweat profusely in freezer. Solar radiation pressure is not subtle. When photons from sun hit dust particles, they transfer momentum. Tiny push, but relentless. Over time, overcomes weak gravity of comet and drives dust particles away from sun. Every comet ever photographed shows this. Tail always points away from sun, always, except 3I Atlas shows scattered light extending twice as far towards sun as away from it. Hubble image is unambiguous. Enhancement of data makes it even clearer. More stuff sunward than anti-sunward. Avi Loeb and Eric Quito published models suggesting this could happen if object sheds large ice fragments from sun-facing side. Those fragments survive longer because they're bigger, creating extended snow line in solar direction. Physics works on paper. Ice fragments of specific sizes ejected at specific velocities under specific conditions of solar heating. But those conditions incredibly narrow, need preferential ejection from day side. Need fragments large enough to resist radiation pressure, but small enough to scatter visible light efficiently. Need evaporation rate just right, so fragments survive long enough to create observed distribution. It's possible, barely. Same way it's possible to flip coin 50 times and get heads every time. Laws of physics don't forbid it, but probability makes you wonder if coin is weighted. And this is pattern. Every anomaly has natural explanation that works if you're willing to accept 3I Atlas is uniquely configured in ways no other comet has ever been. Mass can be explained if uncommonly dense. Trajectory can be explained if statistical fluke happened. Chemistry can be explained if exotic processes occurring. Polarization can be explained if dust grain distribution unlike anything cataloged. Each explanation plausible in isolation, but they're not in isolation, they stack. 7 anomalies, each requiring own special pleading, all occurring in same object. At what point does simplest explanation stop being natural and start being designed? October 1st, 2025, 12:01 a.m. United States federal government officially shut down. Within hours, 15,000 NASA employees received furlough notices, sent home, labs went quiet, offices closed, ongoing research ground to halt. For most of agency, work stopped entirely, but not for everyone. Small fraction, just over 3,000 people, classified as essential. Required to keep working. They won't receive paychecks during shutdown. They'll log hours and hope for back pay when government reopens. But they have to show up because work they do literally keeps spacecraft alive. Mission control operations for International Space Station continued uninterrupted. Ground controllers still monitor life support systems, prepare and validate commands, respond to emergencies. About 1,000 commands per day flow from Earth to ISS. If those controllers were furloughed, astronauts' lives would be at risk, so they work unpaid while Congress argues over budgets. Other major exception to shutdown, Artemis program. NASA's effort to return humans to Moon. Acting administrator made agency's priorities crystal clear in social media posts before shutdown. China is not going to Moon with good intentions. Implication obvious. Beating China to lunar surface considered national security imperative. Important enough to exempt thousands of workers from furlough. This includes employees working on Artemis 2, crewed test flight around Moon, scheduled for February 2026, and Artemis 3, actual moon landing mission planned for mid-2027. Also includes contractors at SpaceX and Blue Origin developing lunar landers. Contractors told to keep working through shutdown. Logging time without immediate payment, because Artemis cannot be allowed to slip further behind schedule. But here's what shutdown doesn't tell you. Crisis at NASA began long before October 1st. Earlier in 2025, Office of Management and Budget and Acting Administrator issued directives to slash workforce by more than 4,000 employees. From end of September through January 9th, 2026, thousands of longtime NASA employees leaving through deferred resignation offers, over 20% of workforce, gone. And it's not just numbers. These resignations included top-tier talent. Engineers who worked on Artemis systems, scientists managing planetary missions, experts in power systems, propulsion, life support. One NASA employee at Johnson Space Center, speaking anonymously, said agency lost at least one foremost expert in power systems. Critical loss for developing nuclear reactor needed to generate power on Moon. Exodus driven by budget uncertainty and political pressure. President's proposed budget for fiscal 2026 requests lowest NASA funding since 1961, adjusted for inflation. Year Alan Shepard became first American in space. Budget proposal includes devastating 47% cut to science programs. If enacted, would cancel 41 missions, including spacecraft already launched and making discoveries. Think about that. Not missions still being planned. Missions already flying, telescopes already observing distant galaxies, probes already exploring other planets, satellites already monitoring Earth's climate. Proposal would literally turn off spacecraft journeying through solar system for decades, wasting billions of taxpayer dollars, erasing knowledge that can never be recovered. List of threatened missions reads like greatest hits of space exploration. Nancy Grace Roman Space Telescope, flagship observatory designed to discover hundreds of thousands of exoplanets and survey over billion galaxies, canceled despite being nearly complete. OSIRIS Apex, currently on way to study asteroid Apophis during close Earth flyby in 2029, shut down mid-flight, Mars sample return mission, despite already having samples sitting on Mars waiting to come home. Abandoned, potentially allowing China to beat America returning Martian material to Earth. Even missions already proven their worth aren't safe. Chandra X-ray Observatory, observing high-energy universe since 1999, making discoveries reshaping astrophysics. On chopping block, Hubble Space Telescope, perhaps most famous scientific instrument ever built. Could see mission support reduced or eliminated. Proposed cuts don't just affect space exploration. Earth science missions monitoring climate change, tracking deforestation, measuring sea level rise, providing data essential for weather forecasting and disaster response. Also targeted, planetary defense programs designed to find and track asteroids that could threaten Earth, reduced funding, ironic given recent surprise flyby of asteroid 2025 TF. Whistleblowers within NASA spoke out. Noted imposing budget that hasn't been approved by Congress is illegal, defies constitutional principles. NASA's legal office should know better, one said. They should know what this administration doing is breaking NASA procedures, regulations, not following will of Congress. But violations continue, often hidden from public view. And while NASA crumbles, while workforce hemorrhages expertise, while missions get canceled, 3I Atlas made its closest approach to Mars, and we got fuzzy dot. Let's lay out timeline. July 1st, 2025. 3I Atlas discovered. July through September. Scientists detect multiple anomalies, unusual trajectory, impossible chemistry, thermal contradictions, WOW signal alignment. September. Avi Loeb begins publishing calculations showing statistical improbabilities. October 1st. Government shutdown. 15,000 NASA employees furloughed. October 3rd. 3I Atlas makes closest approach to Mars. 7 spacecraft watching. Best observation opportunity ever for interstellar visitor. October 3rd, same day, amateur astronomer captures image showing angular structures. October 4th, anonymous 4chan post claims insider ESA knowledge. Details chemical and thermal impossibilities. October 4th, Perseverance captures streak image that calculations suggest is 50,000 kilometers long. October 5th, social media posts about 3I Atlas begin disappearing. Algorithmic suppression ramps up. October 7th, 8th, ESA releases fuzzy images. Public backlash immediate. October 7th onward, NASA, China, UAE remain completely silent. No images released. October 8th onward, Representative Luna contacts Loeb for analysis. Sitting congressperson seeking external expert opinion on Mars photograph. October 29th, 30th. 3I Atlas reaches perihelion, behind Sun, hidden from all Earth-based observation. Early November, object emerges. Trajectory analysis will reveal if course changed. February 2026, ESA's JUICE spacecraft data from November observations becomes available. Every step of this timeline raises questions. Why did government shut down exact week of Mars flyby? Coincidence that NASA went dark right when we needed them most? Why are multiple space agencies, multiple sovereign nations all silent simultaneously about most significant interstellar object in years? Why did social media suppression ramp up within 48 hours of ESA photo release? Why is sitting US representative bypassing NASA to get expert analysis? Why does object reach perihelion at exact moment when it's hidden from every telescope on Earth? Any single data point you can explain. Government shutdowns happen, bureaucracies move slowly, Social media algorithms change. Orbits are what they are. But pattern is harder to dismiss. August 2025, 2 months before Mars flyby, before shutdown, before viral posts. Bertie Jaworski, professional remote viewer, former vice president of Farsight Institute, nearly 30 years experience, master's degree in digital forensics. Not profile of someone chasing internet fame with wild claims. Friend gave her set of coordinates, just numbers, no context, no photographs, no news articles. This is how legitimate remote viewing works. Target remains completely blind. Viewer has no idea what they're looking at until after session complete. Bertie sat down, entered protocol, began describing what she perceived. First thing she reported, movement through space, something traveling, something old, very old. She described it as natural object, icy, rocky, exactly what you'd expect if someone asked you to remote view Comet. For a while, that's all it was. But then she noticed something unusual. There was something that wasn't completely natural, she said later in podcast. There was something strange. She kept going deeper. That's when she perceived it, something small, about size of thumb drive, something deliberately placed inside object, not on surface, inside. Someone had bored into this rock, she reported, bored into this icy rock deliberately and placed something encoded with all kinds of information. It's kind of like archive, message in bottle, but it's not just message, it's technology of some sort. Pause. Think about what she's describing, not alien beings, not massive spacecraft. Thumb drive-sized piece of technology, ancient beyond measure. Hidden inside Comet traveling through galaxy for billions of years. She went further. This thing is so old, and even though object itself is like billions of years old, thing that was placed inside of it is also very, very old. Did some species there on other side of galaxy send up little robot to bore into it and stick their little message and technology knowing this thing was going to keep traveling? Question sounds like science fiction until you remember we've done exactly this. Voyager probes carry golden records, time capsules designed to survive billions of years in hope someone someday might find them. Idea of using natural objects as vessels for messages is not alien to us. We just haven't thought about it in reverse. Friend who gave Bertie coordinates waited until after session to reveal what she'd been viewing. 3I Atlas, interstellar object that would not make headlines until weeks later. She'd been viewing something most of world didn't yet know existed, but Bertie wasn't finished. She did 2 more sessions, going deeper, trying to understand what she was perceiving. In those follow-up sessions, she discovered something that changed entire picture. It's also broadcasting. These messages come out in pulses. Broadcasting, present tense. Not was broadcasting billions of years ago, is broadcasting now. When podcast host mentioned Avi Loeb published calculations showing 3I Atlas arrived from same region of sky as WOW signal from 1977, Bertie didn't hesitate. That's super interesting. It's very possible that is the WOW signal. Multiple other remote viewing groups, working independently, no contact with each other, targeted 3I Atlas in following months. Specifics varied, but certain themes appeared again and again. Technology, deliberate placement, broadcasting, non-human intelligence. One group reported perceiving humanoid forms associated with object. Another described what they called graffiti, signatures. Someone had signed it. Several viewers reported sensation of object being masked, deliberately avoiding detection, as if it didn't want to be fully seen. One detailed report mentioned special access, extraction points, timeline. Not vague mystical impressions. Specific technical details sounding more like intelligence briefing than psychic session. Does any of this prove 3I Atlas is sending signals? Of course not. Remote viewing, even at most rigorous, remains in realm of anomalous cognition, not hard science. These are subjective impressions filtered through human consciousness. but they're remarkably consistent across multiple independent viewers. And they align in eerie ways with physical anomalies telescopes were detecting. If there actually was thumb drive-sized device inside ancient comet, deliberately placed billions of years ago, what would we expect to see? We'd expect it to look like comet from distance. Ice, dust, outgassing, all normal signatures. But up close, we might notice things that don't quite fit. Unusual chemistry, unexpected materials, behaviors seeming designed rather than random. We'd expect it to be massive, far more massive than visible size suggests, because there'd be something dense at core, something that doesn't sublimate away. And we'd expect it to be transmitting. Not loudly, not obviously, but if you knew where to look, if you had right instruments pointed in right direction at right time, you might detect something. Pulse, pattern, signal that shouldn't be there. Bertie Jaworski perceived all of this in August, before most scientific data was published, before anomalies became undeniable, before NASA went silent. She described message and bottle traveling through galaxy. And now, as 3i Atlas hides behind sun, as official channels refuse to release images from Mars flyby, as amateur astronomers report cylindrical shapes and scientists detect impossible chemistry, that bottle is getting closer to perihelion, point of maximum heat, maximum stress, point where, as Avi put it, confessions are elicited. If there's thumb drive-sized piece of technology buried in heart of this comet, October 29th is when it will either reveal itself or remain hidden forever. And fact that NASA sent 15,000 employees home right before we could get our best look raises question remote viewers have been asking since August. What did they see that were not being shown? Early December 2025, 3i Atlas will emerge from behind the sun like a swimmer surfacing after a long dive. Astronomers will find it in the constellation Virgo, low on the eastern horizon in the pre-dawn hours. Magnitude 12 or 13, too faint for amateur telescopes, but well within reach of professional observatories, and everyone will be watching the numbers. Orbital mechanics is one of most precise sciences we have. Newton's laws refined by Einstein's relativity allow us to predict where object will be years in advance. Down to kilometer, we can account for gravitational perturbations from planets, radiation pressure from sunlight, even subtle push of outgassing as comets shed material. When 3i Atlas reappears, its position will tell a story. If it's exactly where pure gravitational calculations say it should be, give or take expected deviation from outgassing, then we can reasonably conclude nothing unusual happened during its time behind the sun. It passed perihelion, survived heat, continued on predetermined path into outer solar system, and eventually back to interstellar space. But if position is off, if trajectory shows changes that cannot be explained by known forces, then every paper written about this object will need addendum. Every assumption will crack open. Because objects don't just change course on their own, something has to push them. Vera Rubin Observatory will play a crucial role in what happens next. This telescope, recently operational, represents revolution in how we survey sky. Previous asteroid surveys found around 20,000 new objects per year. Rubin found 2,114 asteroids in its first 10 hours. 10 hours, 2,000 asteroids. When Rubin turns attention to searching for interstellar objects, trickle becomes flood. Scientists estimate we could be detecting dozens of interstellar visitors per year instead of one every few years. And each one will be studied with lessons learned from 3i Atlas fresh in our minds. We'll know what to look for: chemical signatures, polarization characteristics, trajectory alignments. If 3i Atlas is truly anomalous, we'll have other objects to compare it against. If it's first of new category, Rubin will find its siblings. But December isn't just about orbital mechanics and future surveys. It's about questions building since July. What did Mars orbiters actually see? By December, government shutdown will be long over. NASA back at full staff. High-resolution images from October 3rd will have been processed, analyzed, either filed away or prepared for publication. Those images, taken when 3I Atlas was just 29 million kilometers from camera, could resolve features on nucleus if coma wasn't too dense. 5-kilometer-wide object at that distance should show structure, not fine detail, but gross morphology. Is it round, elongated, irregular? Are there variations in brightness suggesting different materials on surface? Does it look like other comet nuclei we've photographed, or is it something else? The fact that these images haven't been released raises questions that won't disappear just because calendar turns to December. Scientific data usually published as quickly as possible. Competition to be first with new findings is fierce. Multiple space agencies observe 3I Atlas at Mars. None released detailed imagery. Either images confirm it's just unusual comet, or absence of images becomes its own answer. Radio astronomers will also be watching. If 3I Atlas was source of WOW signal in 1977, and if it's still capable of transmitting, December provides another opportunity. Multiple radio telescopes have been quietly monitoring region where objects should be. Not with fanfare of SETI's usual campaigns, but with steady, patient observation. Any signal, any pulse, any pattern in radio frequencies correlating with object's position would be revolutionary. Hydrogen line at 1420 megahertz. That's frequency to watch. That's where WOW signal appeared. If 3I Atlas has something to say, that's where it will say it. December 19th marks moment of closest approach to Earth, 1.8 astronomical units, roughly 270 million kilometers. Not close by any measure that matters for safety, but close enough that parallax becomes significant. Parallax is apparent shift in object's position when viewed from different locations. As Earth orbits Sun, our viewing angle on 3I Atlas changes slightly. By measuring shift with extreme precision, we can triangulate objects' exact distance and velocity. Any deviation from expected values becomes immediately obvious. Observatories across globe will coordinate observations. Northern and southern hemispheres, different longitudes providing round-the-clock coverage. Amateur astronomers will contribute data alongside professionals. One of most thoroughly documented observations of any solar system object in history. And somewhere in all that data we'll find either confirmation or contradiction. Confirmation this is, despite everything, natural object from interstellar space exhibiting rare but explainable characteristics. Ambassador from another planetary system. Strange because it formed under different conditions than our solar system's comets, but ultimately following same physics, or contradiction. Something in trajectory, chemistry, behavior that cannot be reconciled with natural origins. Data point that breaks model, evidence forcing us to consider what we've been avoiding considering. By late December, 3I Atlas will be fading again as it recedes from Sun, moving into constellation Leo, heading back out toward orbit of Jupiter, which it will pass in March 2026. After that, outer solar system, Helios Heath, interstellar space. One way or another, December will give us answers. Not all answers, but enough to know whether we're watching greatest comet show of our generation, or greatest upheaval in human understanding since we realized Earth was not center of universe. Telescopes are ready, equations prepared, world watching. Now we wait for 3I Atlas to emerge from behind Sun and show us what it really is. Let's play this out. Suppose 3I Atlas really is interstellar probe. Suppose it's been broadcasting signals. WOW signal was its way of announcing arrival. What happens next? First, confirmation. If December observations show trajectory changes or radio emissions, scientific community will mobilize. Papers published, data shared, telescopes around world focus on this object. Confirmation process will take time. Months probably. Science doesn't move fast. Every claim challenged. Every alternative explanation explored. But if evidence holds up, if multiple independent teams reach same conclusion, then at some point consensus will shift. We are not alone. We have been visited. Implications are staggering. not just scientifically, philosophically, religiously, politically. Every human culture would have to grapple with knowledge someone else is out there, that we're not unique, that intelligence has arisen elsewhere and reached level where interstellar travel is possible. Financial markets might crash, as Avi Loeb suggested, not because of immediate danger, because of uncertainty. How do you value assets in a world where everything you thought you knew just changed? Governments would have to respond. United Nations has protocols for contact scenarios. But they've never been tested in reality. Religious institutions would need to reconcile teachings with existence of non-human intelligence. Some faiths would adapt easily. Others would face theological crises. Then there's question of intent. Why send probe? What is it here to do? If purely observational, gathering data about our solar system and planet, that's relatively benign. We do same thing with our probes. But if it's doing something else, if it's meant to interact or intervene, that raises questions we're not prepared to answer. Remote viewers who described extraction points and special access were touching on this. What if it's not just watching? What if it's supposed to collect something? Sounds paranoid, probably is paranoid. But when dealing with technology from unknown source with unknown capabilities and unknown intent, paranoia isn't entirely unreasonable. Another question, why now? If probes have been passing through solar system for millennia, why is this one exhibiting behaviors we can detect? Why is it broadcasting if that's what it's doing? One possibility, it was always doing this. We only just developed technology to notice. Before radio telescopes, before space missions, before sophisticated spectroscopy, we couldn't have detected these anomalies. Another possibility, it activated recently because it detected something. Maybe Earth's radio emissions, maybe our spacecraft. Maybe simple fact, we're now looking and it knows we're watching. If it adjusts behavior based on observation, that implies level of autonomy and intelligence we're not prepared to deal with. Now suppose opposite. December arrives. 3I Atlas exactly where it should be. No trajectory changes, no radio signals. All anomalies turn out to have boring natural explanations. That would be disappointing to some, vindicating to others, but it wouldn't be end of story. Because even if 3I Atlas is just Comet, questions it raised are still valid. Why is its chemistry so unusual? Legitimate scientific puzzle worth solving. How common are interstellar objects? Vera Rubin Observatory will answer that in coming years. Should we be prepared for possibility of artificial objects entering solar system? Yes, even if this one isn't, someday there might be one that is. Speculation around 3I Atlas has been intense, some irresponsible, wild claims with no evidence, panic for clicks. But some has been thoughtful, people asking reasonable questions about object that doesn't fit expectations. That's how science progresses. Notice something weird, ask why. Look for answers. Sometimes answers are mundane, sometimes revolutionary. Either way, you learn something. We began with NASA going silent. 15,000 employees sent home same-day interstellar object past Mars. We looked at fuzzy photographs that raised more questions than they answered. At amateur astronomers capturing structures professional agencies wouldn't show us. We examined anonymous leak claiming insider knowledge of impossible chemistry, thermal contradictions, trajectory precision suggesting design rather than chance. We traced connections to 48-year-old radio signal from same region of sky, calculated power requirements for transmission across 600 astronomical units. We stacked anomalies, nickel without iron, tail pointing wrong direction, orbital inclination less than 5 degrees, 7 statistical improbabilities occurring in same object. We watch social media suppress discussion, fact checkers label speculation, platforms' algorithm suppression ramp up exactly when public interest peaked. We noted government shutdown timing, multiple space agencies going silent simultaneously, sitting congressperson bypassing NASA for external analysis. We listened to remote viewers describing technology inside ancient Comet. broadcasting in pulses, message in bottles sent billions of years ago. And we realize 3I Atlas will reach perihelion behind Sun, hidden from every telescope on Earth during moment that should reveal its true nature. Each piece of this puzzle carries uncertainty. Could be explained away individually, coincidence, measurement error, bureaucratic dysfunction. But pattern, accumulation, compound improbability. That's harder to dismiss. In less than 72 hours, 3I Atlas reaches perihelion. We won't see what happens. We'll wait for November, for December, for object to emerge and trajectory to be measured, for radio telescopes to finally point and listen, for NASA images to eventually surface or not, for answers that may confirm our comfortable assumptions about universe, or shatter them completely. A.V. Loeb won't rank this object lower than 2 on his scale. Even best-case scenario, anomalies too persistent, too numerous, too correlated to dismiss as natural with complete confidence. We can't definitively rule out artificial origin without more data. That's where we are, suspended between probable and possible, between natural visitor and technological artifact. Questions we're asking now are among most profound ever posed. What is universe made of? How did life begin? Are we alone? And if we're not alone, if visitors do come, will we recognize them? Will we be ready? October 2025 might be moment we learn answer, or might be another chapter in long human story of looking up and wondering. Either way, we'll know more in December than we know now. Telescopes watching, equations prepared, world waiting. For 3I Atlas to emerge from behind Sun and show us finally what it really is.